Okay, everybody, this right here, we just finished the tumble buggy unit where you guys collected data a while ago about the tumble buggy, and then we figured out that that kind of motion, that position time graph for the tumble buggy that had a constant slope, that was constant velocity. And now we're going to look at a different kind of motion once I find my. So this right here, folks, is called the Go Car because it actually says Go Car on it. And I'm going to put this on the track, and this track is obviously not level. The Go Car is not a powered vehicle like the buggy was. It has extremely low friction wheels and can roll for a long time. So, make some observations here of the Go Car, and then hopefully we'll figure something out. So this is what the Go Car looks like when it goes down the track. Let's see that again. Now, I don't know about you, but that doesn't seem like constant velocity motion to me. So because this doesn't appear to be constant velocity motion, that's different than the tumble buggy. So we're going to do a little experiment here, and it's called the Go Car Lab because it's not a tumble buggy, you see. And for the Go Car Lab, we do have time and position as our variables still. We're still looking at where the buggy or where the Go Car is at a specific time. So we separated into groups, and again, if you weren't here, then obviously you didn't collect the data. So like we have been doing, 7 to 8 data points will be our normal. Also remember a large range. That means, this is what we observe here, okay? This doesn't look like constant velocity. It seems to speed up. Let me back away from the screen here. So it seems to speed up. Doesn't look like constant velocity. And so the goal here is to see what does the relationship between position and time look like for an object that looks like it's speeding up. So that's what we're looking for. We're looking at the relationship between position and time. I should probably have written that down. Let's see here. Relationship, oh my goodness, relationship, between position and time for an object that, there we go. So relationship between position and time for an object that doesn't look like it's going at a constant velocity, that it seems to speed up. That's what we're looking at here. And so again, 7 to 8 data points. We want a large range, so we want to use the entire track. That track's over 1.5 meters long, like 160 some centimeters. So we want to use the whole track from short positions all the way out to long positions. And we're going to repeat and do 2 or 3 trials per data point and then average those times because it will create better data for us, like we figured out with the tumble buggy lab. And notice position is still on the vertical, most likely measured in centimeters since you're using meter sticks in the room here. And of course time measured in seconds on the horizontal or x-axis. So that is what we were doing in class and did in class. If you weren't here, then I will be sending you data from a group so that you can have all of this stuff done while at home. Also, make sure in your comp book you have what's on the board right here written down. And then you will sketch for the XT graph here, you will sketch in your comp book the shape of what your graph looks like. You will put your data here, the data that you collect, you will put that into Graphical Analysis, the app that we were using for graphing. You will use Graphical Analysis, you will put your data in Graphical Analysis, and the assignment that is posted on Classroom has you uploading a picture of all of this, so your data that you collect, the graph sketch, what your graph looks like in a paper pencil sketch. You don't have to scale and plot the paper pencil graph. You literally will just draw a line. You'll set it up just like I have it written here with the position and the time shown. You will sketch what the line looks like in your comp book after you have put your data into Graphical Analysis, and then Graphical Analysis will do the graph for you, and then we'll show you what that graph is supposed to look like. Then you can sketch what this looks like in your comp book from the Graphical Analysis app. And so for the assignment, you will upload a picture of everything that's in your comp book, and you will upload a screenshot of the graph from Graphical Analysis app. So hopefully everybody understands what I'm saying right there. So those are the two things you're going to need to upload. You need to upload a picture from your comp book with the data and the graph sketch, and Graphical Analysis, the app, screenshot of your graph all typed in with the axes all labeled, like your position and your time axis need to be labeled in Graphical Analysis like we do that. Punch in your data, put a fit, like a best fit on the graph in Graphical Analysis, and then you'll turn that in. So I think that's it. It's too bad you missed the data collection, but I'll try to send everybody that wasn't here a set of data from someone. So that's their track with GoCar, and I'll see you on the flip side.